Alright, today we're going to have a look at some harder simple harmonic motion. Now in extension 1 we've looked at something that's known as harmonic addition, which in extension 1 we called the auxiliary angle method. And this is where we added sine and cosine functions to create a new sine or a new cosine function. Now because of that, that means that functions in the form x is equal to a sine nt plus alpha plus b cos nt plus alpha plus c are also in simple harmonic motion. So we've got a particle moves with an equation x is sine 2t plus cos t plus 3, and we have to prove that the particle is in simple harmonic motion. So we're just going to apply our auxiliary angle method work, and if we have a go at going, okay, well that means 1 squared plus 1 squared is root 2. And we're going to use sine in the natural form, cos, and we're going to do tan inverse of 1 over 1, which is pi on 4. So it's going to be 2t plus pi on 4 plus 3. And that's in simple harmonic motion, which is in the form a sine nt plus alpha plus c. So that's in simple harmonic motion. Okay. Something that was definitely in the old syllabus but is a bit vague in the new syllabus, and no one's really sure whether they will examine this or not, is velocity as a function of displacement in simple harmonic motion. So another way of expressing simple harmonic motion is through this equation here. V squared is equal to n squared a squared minus x minus c squared, where n is some constant, a is the amplitude, and c is the center of motion. So the second example in today's video is we're going to prove that this type of graph is in simple harmonic motion. Now, we know that simple harmonic motion is any movement that's in the form a sine nt plus alpha plus c. Now, another name for velocity is x dot. So let's find x dot. X dot is going to be a n cos nt plus alpha plus c, and if we square that, because this equation is v squared, we're going to get x dot squared, or v squared is a squared n squared cos squared of nt plus alpha. Now we're trying to now prove that this equation is in simple harmonic motion, and we're trying to deduce that this equation in simple harmonic motion is the same as this equation here. So what we might do is think, okay, the only way I'm going to get x's in this equation is if I replace x with what we've defined it to be, which is sine. So we're going to have to replace cos squared with sine somehow, and we might remember that this is the same as 1 minus sine squared from that Pythagorean identity we saw in, we've seen heaps and heaps of times. Okay, we might pull through that a squared now, so that's going to be a squared minus a squared sine squared nt plus alpha. And then what we might do is, so we've got a squared minus a squared sine nt plus alpha. Then the next thing we might do is, I reckon we work with the other equation, or what have they done here? A squared minus, they've realized that this is a difference of two squares here, I'm pretty sure is what they've done. So we can say that this is n squared a minus a sine nt plus alpha, and then this is going to be a plus a sine nt plus alpha, and then what we've got, this is n squared a minus a sine nt plus alpha. But then we need a plus c and minus c because we want to try and replace it with x. So now this is x here. Let's do that to the other side as well. All right, so we've got n squared a. Now we're going to have to pull out a negative from here. So this is going to be a sine plus or minus a sine nt plus c, or plus alpha, minus c. And then this is going to be, or plus c minus c, plus c, minus c. And then this one is going to be, so that's going to be a second plus c there because that minus c is there. And then this is going to be a plus a sine nt plus alpha plus c minus c. So here we've got n squared a. Now this here is x, as is this here. So this is going to be a minus x plus c. And this one over here is going to be a plus x minus c. And we can have a go. So this is going to be n squared. Now this is a minus x minus c. And this is a plus x minus c. Now that's a difference of 2 squared. So this is n squared. If we expand that, we're going to get a squared and then minus a x minus c plus a x minus c and then minus x minus c squared, which is what we were trying to prove. So therefore, v squared is equal to n squared outside of a squared minus x minus c squared. Okay. The second example in today's video is we've got a particle is moving in simple harmonic motion about a point x is 2 with a period of pi on 2 initially at rest is at the origin. Derive an equation for v squared as a function of displacement. Okay, so part 1, we're going to realise that a particle in simple harmonic motion has an equation minus n squared outside of x minus c. Now the centre of motion is 2 and the period is pi on 2. So pi on 2, our equation for period is 2 pi on n. So 2 pi on n, that means n is going to equal 4. So therefore x double dot is going to be minus 4 squared x minus 2. We're allowed to assume this definition for acceleration. It's on the reference sheet and it's something that we can assume. So that's going to be minus 16 x minus 2. And we want to derive an equation for velocity squared. Now we can't assume this formula here. It's no longer in the syllabus, but we can utilize our knowledge of mechanics to find an equation that that represents this equation and exists in the same form. So we've got x double dot, which is acceleration. So x double dot is equal to this. And we want to try and get velocity squared as the subject, and whenever you've got velocity squared as the subject and x is what its terms of, that's when you're using d by dx of a half v squared. And we're going to integrate both sides, so that's going to, if we integrate this, they're going to die, integrate that, so this is a half v squared equaling minus 16x squared plus 16 times 2 times 2, 16, we've got plus, I might just keep that there, minus 16, and that's going to be x squared minus 2x plus c. Now if we multiply everything by 2, we're going to get v squared is equaling to Oh, I think we're going to put it, on 2 there, so 16 on 2. So we're going to have minus 16x squared plus 16 times 2 times 2 is 64x plus c. Okay. Now we do know that the particle is initially at rest and at the origin. So v equals 0, x is going to equal 0. So 0 is equal to 0 plus 0 plus 0. So c is equal to 0. So therefore v squared is equal to minus 16x squared plus 64x. Okay, part 2 says find the values for which the particle is at rest. That's just when velocity is 0. And if we solve that, we're just going to get x is 0 and 4. Okay, the next question says find the maximum velocity of the particle. Well, we do know that v squared is equal to minus 16x squared plus 64x. Now we do know the maximum velocity. You could differentiate this, but the maximum velocity occurs at the center of motion. And the center of motion is, let's see, the center of motion is 2. So by definition, maximum velocity occurs when it's at the center of motion. So we're evaluating when this is 2. And if you do that, you get, well, v squared is equal to 64. So the maximum velocity is 8 meters per second. Right, the next example, we've got a particle moving in simple harmonic motion. Its equation is v squared is 24 minus 8x minus 2x squared. We want to find an expression for the acceleration of the particle in terms of x. Now, don't get confused. You can't differentiate velocity in terms of x and get acceleration. We've seen that a lot of times before in this topic, and that's because the definition of acceleration is either dv to t or the 2x to t squared, not dv to x. That is not the definition of acceleration. You can't differentiate this and get acceleration. If you want acceleration and you've got x being the subject, the two things you can use are v to v dx or a half v squared d by dx. In this instance, since there's x's in it, it's going to be easier to use d by dx of a half v squared. So we're going to realize that acceleration, x double dot, can be expressed as d by dx of a half v squared. So we need to find d by dx. Well, a half, or already v squared, it's already been squared, so we just need to half it. So 12 minus 4x minus x squared. Differentiate him, you get minus 4 minus 2x, which is minus 2. Now, technically, this is an expression for acceleration. In fact, this is an expression for acceleration, but it's in simple harmonic motion. So we're going to express its acceleration in the form of simple harmonic motion, which is x double dot is equal to minus n squared x plus c. So this is going to be minus root 2 squared. And I guess technically the definition of simple harmonic motion is x minus c, because we want to know the center of motion, and the center of motion in this instance is not 2 because it moves it off by minus 2. So the center of motion is c, but we don't have c in this case here. We've got minus c, so we might want to express it as x minus 2. That's because the definition of simple harmonic motion, there has to be a minus here, so the center is minus 2, not 2. Okay, so there we go, that's our expression for acceleration. Part 2 wants to know the center and period. Right, so the center is minus 2 again. If you write 2, it's wrong. I'm sorry, that's because the definition of simple harmonic motion has a minus there. Now, n is, well, the period is 2 pi on n, and n in this instance is root 2. That n comes from there. So we've got 2 pi on root 2. So the period, well, 2 on root 2 is just the same as root 2. So the period is root 2 pi. Okay. 2 more examples. Example 5, got a particle is moving with an equation of motion v squared plus 9x squared is equal to k, where k is a positive constant. Show that the particle is in simple harmonic motion with period 2 pi on 3. So we know the equation, we've got v squared is k minus 9x squared. Now to show that something is in simple harmonic motion, we can either A, prove it satisfies the sine equation, which is our displacement, or prove it satisfies x double dot, which is the more common thing we're going to do. X double dot is minus n squared x minus c. Again, making sure you've got that minus there, not a plus. Now, the way we've seen to differentiate this is to realise that x double dot is d by dx upper half v squared, which is going to be, we can't really half this because they're both odd coefficients, so we're going to leave the half out there, and we're going to find d by dx of just k minus 9x squared, which is going to be minus 18x times by a half, which is minus 9x. And we want to put it in a simple harmonic motion form, so it's going to be minus 9. If we really want to be annoying, we could do that just to show you it is in simple harmonic motion, which is minus 3 squared x minus 0. But who can be bothered to write that 0? So we're going to say minus 3 squared times x. So therefore, it's in simple harmonic motion. N is equal to 3, period, is 2 pi on n, which is 2 pi on 3. Okay. Last example for simple harmonic motion, we've got an equation there and we want to know a possible equation for a function of time. So we should remember that all functions that are in simple harmonic motion have this particular formula here. And we're going to try and find that form there. Right, so we do know in this instance that v squared is equal to 16 outside of 5 plus 4x minus x squared. And we want to try and get it in the form. What form have we been using? Because it's not quite in any form that's useful for us. We want it in the form v squared is equal to n squared a squared minus x minus c squared. Okay. To do that, we want to have to complete the square. So we might take out a negative factor and say this is x squared plus minus 4x minus 5. And if we complete the square, it's going to be, take out that minus, that's going to be x, might have another bracket there, square bracket, negative, x minus 2, completing the square, and that's going to leave us with a plus 4 if we expanded that, but we initially had a minus 5, so we need a minus 9 to get to minus 5. Pull back through that negative, we're going to have 16, 9 minus x minus 2 squared. Right, so there we go, n squared is equal to 16, a squared is equal to 9, and c is equal to 2. So therefore, we know simple harmonic motion exists in the form a sine nt plus alpha plus c. So a we've said is 3, sine, n we've decided is 4t, alpha phase shift is just 0 plus 2, and that's our answer. Alright, thank you.